I'll just give a brief introduction about our speaker. She is Dr. Nikhat Khan, madam, and she is having a very good education background. Under this, she has acquired Doctor of Philosophy in Computer Science from Mewar University in December 2018 with specialization on ad hoc network and security. Her Master of Technology in Information Security from Maulana Azad National Institute of Technology, Bhopal in May 2009, with the title of her thesis is Edge Education Technique Using Fuzzy Logic. She has more than 10 years of experience in education and research. She has authored more than 35 research publications in national and international journals and conferences. She is certified by IIT Bombay on R program language under spoken tutorial. Gave an expert lecture on R programming as well. She worked as a coordinator of various training program, FDPs, conferences, seminars, and more. As an enterprising engineer, always shows great interest in doing project in the domain of security, machine learning, data analytics, and ad hoc networks. So now I would like to request her to begin the session, and she is going to take a session on big data analytics and machine learning. Up to you, madam.
Thank you so much, sir.
Thank you, ma'am.
Thank you, first of all. Very good morning to all. And thanks to organization team who have given me opportunity to deliver a lecture in big data analytics and machine learning. So good morning to all. So shall we start, sir? Am I
Sure,
audible?
ma'am.
Yeah.
Yes, ma'am.
So please give me a permission of sharing.
If it is not happening, you can just rejoin the meeting
Okay,
because
sir.
sometimes it happens like that.
Okay, sir.
Yes.
Is this my slide is visible to all?
Yes, yes, yes.
This is visible, no?
Yes, ma'am.
Okay, so today's topic is big data analytics and machine learning. So, talking towards big data analytics. So here we are covering our topics for today's lecture. So now today we'll discuss about big data and why big data is needed and where did it come from. So this is the portion of your introduction portion. Then data science, then characteristics which we are covering for big data. So what are the characteristics? Yeah.
Sorry to interrupt, ma'am. Actually, your slides are not. You can just change the screen so that we can see your slides if you are sharing. Yeah.
Slide is not visible.
No, your screen is coming actually.
Okay. This time, sir.
Not yet.
Same as the screen is coming.
No, ma'am.
Okay. Now this time,
Yes, madam. Yeah,
it's
we can.
visible.
Yeah.
Okay, so now I'll start and very good morning to all. This is today's
Okay.
topic is big data analytics and machine learning. So here the topic which we are covering in today's lecture. So the contains which we are using for introduction of big data and why big data is needed and where did it comes from. The data science and then the big data characteristics of big data, the volumes characteristics of big data, that is 4V's: volume, velocity, variety, and more of V's. Then data analytics, then types and analysis we'll discuss on there. data analytics tools, then introduction to machine learning and types of machine learning. So why is big data? I mean, why we are saying nowadays the big data and so many times the big data. So how the big data has come and like why big data is needed. So if we are talking about big data, the term will come from the big data. You know, the data and the big and the data. So data and analytics, the two terms is comprises. Initially, for traditionally, we are doing so many years of our data. We are collecting a data from so many years in a traditional way. So the data that will not fit in main memory. So you can say a large amount of a data. Like you can take an example for the statistics. We can take an examples from many ways, like your contact numbers, in many other terms, like if we are talking about in hospitality, in different fields, banking. So they are the sources of collection of our data. So this is the data, the tradition big data has come. Now, the previously talking to timeline of recent technology developments. So, in recent technology developments, it says data have so many years. It has not so many years. So, previously we are doing in ERP. So, in 1980s, if we are talking to 1980s, so that we are doing as an ERP. Then coming to our CRMs in 1990s, we are moving towards towards other terms. Then like if because of that less of amount of big data, now the larger amount of data. So day by day it will increase. So 1980s and 1990s of CRM, then e-commerce has come. Then in 2000 we introduced as an e-commerce, and then finally in 2010 has a big data analytics. So this is a timeline of recent technology developments of big data. If say why what is a data science and why the data science. In terms of data science is an interdisciplinary field that uses scientific methods, process algorithms, and systems to extract knowledge and insights for structures and unstructured data. So we can say a data isn't any kind of a data, as in raw data or so many things. So the data has come over large many years. So it's an interdisciplinary we can use in our scientific methods. So the process which we are using, such like we are using for the algorithms and systems to extract, this knowledge is comes from our data science. Whether the data is the form of your structured data or unstructured data, in any form, so we can say data. Then data science, uses of data science, so many fields we are using nowadays are data science. Business understanding fields, data mining fields, data cleaning and explorations, feature engineerings, and then predictive modelings and visualization. So these are the fields where we are using for the data science. So every fields in every time we are using our data science. So now, the term big data. So, exactly what is big data? So, in terms is a collection of a data set. So, a large and complex that it becomes too difficult for processing or using of handle of a database. Because in and traditionally, we are traditionally data processing applications over there. So many years we are using our databases. So nowadays, when we are facing a problem of our collection or storing our large amount of our data, then we introduce our big data. So that's why the term of a collection of a data sets and large and complex becomes. The challenges included such like captures, captions, storage, searches, sharing, transfer, analysis, and visualization. So these are the challenges which is include in data science. So we are setting a collection of a data means you can capture your programs, you can capture your images, you can capture your videos, then curations, then we store many things, videos, pictures, libraries, data, so many things, contacts. So we are storing these things. Now the search how we can search, how we can, if we are having a large amount of a data, the what the searching techniques we are using, how we can search is, then sharing the data, and then transfer, how can we can transfer and analyze and visualization. So these are the terms which we are using for the terms in a big data. The train to large data sets due to additional formations are deriving the analysis of a single larger sets than related data. So as we compared for a separate smaller set with the same total amount of data, or we can found a spot business trends to determine quality of research, prevent, then diseases, link legal citations, combat crimes, and determines in real-time roadways traffic conditions. So these trends have coming to our data sets, and due to this additional formation, we derive for the analysis of a single or a large sets of data. Now, what is importance introduction? What is introduction and importance of our big data? So talking to big data nowadays, big data terms is very much is coming in everyone we are doing as in big data. So big data is a term that describes the large volume of a data. Both we can say are structured and structured forms, where that includes our business on a day-to-day basis, or but it does not an amount of data which is important. Is it important of organizations to do the data that matters? And big data can analyze for insights that leads to better decision and strategic business. The uses of big data is becoming common for days and companies to outperform their peers. Now, in most industries, existing or competitors and new entrants like will use the strategies resulting from analyzed data to compete, innovate, and capture the values. So this is an importance of our data. Big data helps to organize, create new growth opportunities, and entirely new categorize, which combines and analyze the industry data. These companies have ample information about a product and service, buyers and suppliers, consumer performance that can be captured and analyzed. So the term, while the term we are using for big data is relatively new, that act of gathering and storing a large amount of information. So eventually, analysis is in ages of old. Okay, so nowadays these things for we are using for our big data. So the term which relative to gathering and storing a large amount of data in and each and every fields. Nowadays no fields have left over in from big data. Each every field, if we are talking about banking side, if we are talking about research side, if we are talking about statistics terms, if we are talking about our any marketing terminologies, e-commerce terms, everywhere we are using for our big data. So the in the World Banks, this is a service survey of SDG related big data projects. So this is the data type of the sources, how they can collect our data. So these are the sources where they can collect our data. They can collect a mobile phone, satellite, web data, financial transactions, scanner, Facebook, sensor, health, slave ships. So these are the government view. They can collect our data from different sources. Talking in terms, if so, you know, these are nowadays industry 4.0. Industry 4.0, it means the industry sites, they have collecting our data from different resources. Talking if we are the research side, so research we are using for the our statistics, the statistics we are using for doing this creating a statistics. So this is the why the big data has important. Now to moving towards big data has an important play a role and characteristics of four V's. Four V's means the four V's of the big data. So four V's is means of volume, velocity, variety, and veracity. Meaning of volume is in the same as similarly as in before. Then velocity, it means it's comparison between speed. Then variety is in comparison between the diversity. And then if veracity, if the data has in doubt, here's an example of what is the volume. So volume, four V's, it means the data volume. So you know the terms of a, talking to the terms of a volume. Terms of a volumes, it's a how much amount of data and forms of a data. So the terms of a volume, it's mean the amount of a data in terms of terabyte. in terms of records, in terms of transactions, there in terms of a tables, files. Okay, not taking to a small amount of a data, a large amount of a data. There's a large volume of a data. So this is our terms of terabytes. Data velocity. So in the velocity, it's kind of near as in time. It's the collected of a data as in time or analyze the data. So when you have analyzed your data, or when the time, so it provides a time. So you can say a nearer time or real time or streams of a batches. So the velocity is tracking to a time. The data variety, so data variety, which kind of a data you have, which kind of a data you have structured data, unstructured data, semi-structured data, or mixed data. You know, the structured data is in simple, it's in general form, it's in simple structured manner. Semi-structured data is in mixed form, such as our XML files. These are the semi-structured data structures, like we are having arranged data. Unstructured data, such like a social media data. Then the variety provides, fourth one is our variety, how the data, what type of a data we have to collect it. So talking a volume, what are the sources of the volume? We can say a zettabyte collection volume of a, what is the volume of your data. Okay, because here's the how much volume you have for data, not an not in a GB. We're not talking about a GB or like your MB and KB. We are saying a zettabyte, petabyte, tetrabyte. In terms of this, it's coming to a volume. What are the scales of a data? So this kind of a data is coming for this of volume. Now, this such like, oh, say billions of a people have using nowadays in the internet or the services of a social media. So many persons have using the different sources, like you are also a part of, you are fetching your the information of a Google, you are searching another thing, such like you are having your mails, you are having so many data. So this is the volume of a data, such like the collection of a data, your Walmarts, so many Walmarts is here in the whole world. So these kind of a collection, these kinds of a social media, these kinds of a collection of a volumes is coming to a volume. Then if coming to the variety, so a different how you can collect a data. So you can say a collection of a data as in different forms, such like your social media, such like your the billions of we are showing up videos, millions of people have performing their Twitters, so many persons have accessing the Facebooks, and then Instagram and other social medias also. Okay, then so the collection in terms of the bytes is an exabytes and millions over there. Then for about 2 billions have they were using for their wireless communication, wirelesses, and then monitors, and then like so many records is here. So how the variety, how different forms of the data means how the data you have collected, what are the varieties. So if you can say a structured data, you can say if you are coming your social media terms, then there is an unstructured data. You can structure data in the terms of content is forms of a structured way. Then you can say a mixed, such like your the XML files. These are the semi-structured data. Okay, so mixed data is combined of this structured and unstructured data. Then the variety of veracity. Then veracity is an uncertainty of the data. So you can say a survey of, you can collections of a survey, how the uncertainty of the data and how the data have come. Then velocity and analysis of streaming data. So you can analyze, can coming to how the trains and informations, what are the sources is coming, the sensors we are using, and billions of our networks have connections. So these 4 V's are the important characteristics of our big data, which is we are using our industries, companies, and everywhere. Now the terms isn't data analytics. Big data isn't a large amount of a data. Now coming to as in data analytics. The types of analytics. How many types of analytics? So you know the sources, traditional and nowadays. Traditional data is a collection of a data, a simple data where you can using and such like your SQL data, you can be are doing a data warehousing, wrangling, and mining. So this is previously we are doing for the traditional data. So if in transactional, so if we can categorize of a types of a data. So this is an aspirations and analytics maturity. So you can see here the data quality. Here is a different of a data quality, and this data we can collect as a descriptive form. That how we can collect, so we can collect our different resources of our data, such like if we are talking to our COVID data. Okay, so these COVID data we can collection on the different cities, then over the countries, and then over whole over the countries. And this can collections we can create our own the graphs as per then is city, then state, then country, then then countries, and then whole world. So this is comprises for with the, and a different charts. Okay, then it's we can say a business intelligence. So we can also examples you can take as an e-commerce nowadays. So e-commerce the sites have been very much active, such like your Amazon, such like your Myntra, Flipkart. So many sites is in the e-commerce sites. Okay, so this isn't descriptive data. Now, how we can diagnose? So we can diagnose or identify the factors and causes, because once we can collect our data from different resources, but there isn't the data is which is related to each other. Is it necessary the data which you are collecting or data which you are creating as statistics? This is a correlate to each other. Then we can identify their factors and causes, and we can diagnose identifying their factors. Finally, which the factors had diagnosis. So coming to forecasting and probability, so we can predict, predictive and perspective and semantic. So predictive means how we can predict what are the data, means the collection of a data. We can predict the kind of a data, which kind of a data you can collect, then you can categorize of this data, and you can forecasting and you can probabilities. So if current scenarios, if I'm taking an example of a COVID scenarios, so you can say COVID has coming a three waves: first wave, second wave, and third wave. In the first wave, we can say the first time the if can affected to the terms as an over the age of 45 plus. What are the symptoms over there? The symptoms were coughing, colding, like temperature, high temperature, and then the shivering of a fever. So this is the then terms we can coming from then first phase. Then second phase has affected to our 45 less than 45 near about to 25 to 45. So this two scenarios, and third scenarios is affect from the kids also. So on which basis we can collect these data? On the basis of our prediction, the which data we can collect. So statistics we can create a three different forms. So this is our predicting, and the basis of this prediction we can form up forecasting. Similarly, perspective, it means understanding our social context and meetings. So we can understand how we can collect all the data which is related to each other, then comings to, and then understand all this context and what the meanings we can finally finalize of this. And then semantics, so optimizing system. Finally, once it's done, though we can create we can optimize our data. Finally, once we can optimize our data, then come to the data visualization. So visualization is in presentation of your data, how you can present your data in terms of your patterns, in terms of your histograms, in terms of your charts, in terms of your the category we are using. So this is are the types of our analytics. Okay, so you can say a transitional to an strategic. Can say coming to the transactional to then strategics. So this is the way that the coming to transaction and the strategics. On the basis of this, we can create analytics life cycle, data life cycle. So finally, initially we can business understandings. So create and business understanding, then data understanding, and then data mining and modeling. So three things are here. Now, business understanding. So gathering the problem information, where we gathered a problem to identify the things. Now defining the goal to solve the problem. So how to gather a problem. Okay, what are the goal after defining? So goal, how to solve the problem, then what expected outcome is over there, then how to define your hypothesis, then analysis and methodology. Coming defined analysis and methodology, then measuring the business values. So finally, these are the steps which we are using for our business understanding. This we are using for business understanding. Okay, now gathering problem. So whenever we are doing anything, we collect a data. So we it means we gather our problems. What is the problem is coming? Then define, and then what expected outcome is, how we can solve this problem. Then presentation of a hypothesis, and then analysis and methodology. Now after this, we are doing a data understanding. So how you understand your data? So in understanding of a data, so define variables to support hypothesis. So define our variables which supports our hypothesis, because we are creating a hypothesis. So define our variables, cleaning and transforming the data, and then we can transform our data, and then we create a longitudinal data and train data, and after this we are doing an ingesting additional data if needed. If any additional data is needed for this, then build analytic data mart. Okay, so this is the part of your data understanding. So now the third life means finally we are coming to data mining and modeling. So we can create a modeling. So defining target variable, defining what are the target as our variable. The target we are using are what the target you are using. So what are the variables we are using for defining our target? Then splitting data for training and validating the model. Splitting data for training and validating. After this, the defining analysis time frame for training and validation, then correlation analysis and variable selection, then selecting right analytic algorithm. So finally, do validation by measuring accuracy, sensitivity, and model lift. So this is our analytic life cycle. So in analytic life cycle, we are doing a business understanding, data understanding, and then data mining and modeling. So this is the life cycles. Now the big data analytics, we can, so in terms of this, we can say the big data, what sources, then perspectives, insights, and why, and then who are big data analytics professionals. In terms of this big data analytics, examine and large and varied data sets. So you can a large examine of a data set. There analyze a large volume of a data for multiple and varied sources, including the transactional data and other structured data. This is the big data in terms of a big data. Sources is gathered from a very wide variety of sources. How we can sources? What are the sources? So we can say a wide variety, such like your including your social network, videos, digital images, sensors, cell transactions, and records. Anywhere. So many sources is collection of a big data, collection of a data. Then business perspective. In terms of business perspective, so effective marketing, businesses like marketing companies and discover new revenues, opportunities, improved customers, services, and more efficient opportunities. Such like if talking to business perspective, so how they competitors have needed, means how the competitors have identified who are my competitors in my field. So in terms of this business perspective, so they can create their marketing. So in terms of the companies, like they are my competitors. Suppose we are having example in Amazon and Flipkarts and Mintras. If talking Ola, Uber, so in terms of they are the competitors, so they can collect our data, and they can see the graph, where the graph is rising for Ola and Uber. Ola have taking the Uber, okay. Amazon has in the Mintra, then their Flipkarts, so many sites. So this is the competitor. So they can make their charts in graphs. You can create and then competitors. Insights, uncover and hidden patterns. Now unknown correlations and market trends and customers preferences. So how they can here it can come as unhidden patterns also. The correlations which is unknown correlations means which we are not able to find out also. So they can, yeah,
Excuse me, ma'am.
yeah.
Ma'am, your slides are not changing.
This
It,
time,
it has been stuck. No, not yet.
okay. Now,
No.
okay.
Yeah, now it. Yeah, now it's fine. Sorry to interrupt. Thank you.
No, sir. No, sir. Thank you so much for this. Now this time, okay?
No, it is on analytics lifecycle.
Analytics life cycle. Now this is what is data analytics. This one
It's
is what is data analytics.
not changing. It's on analytics lifecycle only.
Now
No. Can you just maximize the slide?
this is maximize.
Oh, we are seeing the.
Okay, but this is maximize.
Yeah, okay. Now what is data analytics? Now it came.
But is you are saying it's not maximize.
No.
Now this term is maximize.
Just a second. No.
Why? Can't-
It's fine, man. You can just click on. Yeah, now it is changing. So you have to click again every time, I guess.
Okay.
Not in presentation mode.
Showing analytic life cycle.
Yeah, yeah.
Is it maximize?
No, it is showing like all the we can. It's not in presentation mode. You can just F5 or
This one, but in my ends, this is maximize. That's
oh,
why.
okay. But here
Why
we are
is it
seeing a
come?
different screen.
I again stop sharing then sharing.
Yeah, yeah,
Okay.
no problem.
Sorry for this. Huh?
Not an issue.
Is it maximize for this time? Excuse me, sir. Is it maximize for this time? Maximize? Is it maximize? Not able to hear any voice.
No, ma'am, it's not.
It's not maximized.
No, ma'am.
I think this is happening to many speakers, so not a new issue. But what you can do is just by clicking on the slides, you can just show it. It's fine.
Okay, sir. Now, isn't big data analytics? So we were in here. Okay. So
Yeah, yeah. Stop this screen sharing. So
stop this. Wait. Is it okay?
yeah, yeah, ma'am.
Okay, so we are in here the sources and collection of a business perspective, and then insights. Insights means if we are talking insights, so how we can collect our data. So here we can uncover of another hidden patterns and unknown correlations and trends and customer preferences. So this here can patterns which connects the might otherwise and invisible provides are valuable insights. So who the users who created it, then why. Okay, so why it means help organizations, why big data is necessary, then it helps to organizations make more informed business decision. So gain an edge over there, the reviewers and make supervisors business decisions. So this is above why. Then if you'll become a BDA professional, big data analytics professional. So as in professionals, such as data scientists and predictive modelators, ability to analyze a big data. So this is a complete performance are big data and the sources, then perspective, insights, and then why, and BDA professionals. Now, what is a big data? Then what is a data analytics? So in broad terms, in broad sense, we can in broad sense finding trends and patterns in raw data, because a data in we can say what is data. A data is anything which is a raw materials, a raw, any kind of a data is collection within anywhere. A data isn't anything such as a raw, such like a data you have, your images, your videos, your contact numbers, your word files, any kind of a data, any type of a data is coming to the answer of this data. Then this process which comes, the data is being captured. So sources are so many things, nowadays. So if I take an example, so if I want to predict the mean compensations to packages offered by companies in a placement session, then I need to I need to historical data. Okay, whenever we have placed anywhere or whenever see anything, so first of all, what we'll do their historical, the history of there. So this is the data of a historical. So this is your the data analytics. It helps to business to improve. It helps to government organizations to improve. It helps to researchers to improve and they can see. So this is the data analytics is helps in everywhere. So being at intersections of information technology, being is an intersection of information technology, so statistics and business. So data analytics is integrated previously separate departments in a business. Okay, then it helps to analyze their performance using a key. What key? As in performance indicator key. KPIs isn't performance key, isn't key performance indicators. So this is helps to analyze a business performance. Okay. Now in turn data analysis help business becomes more efficient and more improve performance. So this is the help data analytics is helps the business. Now, data analytics is not a new, it's previously and current. So, analysis has been used in banking and insurance industries from 1990s, because previously I have shown a slide with the timeline of the data analytics. So there 1980s and 1990s and 2000 then 2010 and current scenarios. Okay, so in it uses a analytic analysis is uses a banking and insurance industries in 1919. Then the Business Week publishes articles in 1994, and then starting a companies were collecting a data to predict are likely to customer to buy a product. Then the data science came into a being when the modern data science came into being when William S. Clevens it published a data science and action plan for expanding our more technical areas of a field of statistics. So this is a modern data science. In modern data science, it means our action plan where we can expand for why where action plan is needed for expand technical areas in the field of statistics. Action plan is expanding in the technical areas in the field of statistics. Then what held back data analysis from being popular in 1990s? So that time previously it was a lack of a data analysis due to a lack of the data, because it's difficult to collect a data process. Collection, cleaning data is much harder than previously. Then collecting of a data for storing a central uses for extremely hard and costly. Then companies were not capturing their data to generate meaningful insights. So these are the problems, the lack of a data when previously we have faced. Then lack of a data analysis due to the lack of an analysis. Then manually we are doing this, and through the trying to generate the insights of a trades and often errors of a phones. Its results are personal bias to insight and hence wrong conclusions of them. Then lack of enough competent data analytics. Now, then why is data analysis is the spotlight now? Then why it is needed? Because so these are lacking of a data result in manually trying through the errors have comes, then collection difficult to collect this collecting of not on good data, not on cleaning, harder to collections. So this is the reason they are facing of a data. Then coming to why that is needed. So coming to talking to analysis spectrum. Analysis spectrum in terms of a business intelligence to then advanced analytics. So SQL analytics, then descriptive analytics, data mining, then predictive analytics, then simulation, and then optimization. SQL analytics is coming to count mean OLAP. Okay, in SQL analytics, in structured query language, we can see count, mean, and OLAP. Okay, object labs. Descriptive analytics is unvariate distributions, central tendency, and dispersions. So these are the questions coming and we are studying in our descriptive analytics. Then data mining, so rules, fair use association rules, clustering, featuring extractions. So this is our data mining. Then coming to our predictive analytics. So here in predictive analytics is in the classification, regression, forecasting, spatial, machine learning, text analytics. So this portion is coming to our predictive analytics. Simulation we are doing for Monte Carlo, agent-based modeling, discrete event modeling, and then finally as an optimization. We are performing optimization is linear optimization and non-linear optimization. So this is a chart which is showing our analysis spectrum from business intelligence to advanced analytics. Okay, so business analytics means coming to the first one is an SQL analytics, the previous traditional ways. Okay, then descriptive, then modeling, predictive, simulation, and optimizations. And these are the things which we are taking our analysis spectrum. Now the hardware, in talking to terms of a hardware, so it is high cost and data storage capacity for taking for this, high cost and lack of temporary memory capacity and speed to data transfer. This is the things hardware where we are facing a problem. High cost and low processing power, and from 2010 onwards, hardware started becoming really powerful and most important of all. So these things are coming to problems faced in a previously, where the high cost of and lack of a data storage capacity. And then 2010 onwards, the hardware have started becoming really more powerful. Then GPUs have enabled parallel processing and hence made data processing much faster. Then why do we need analytics? It's needed for the data analytics nowadays. The data analytics helps organizations harness their data and use it to identify new opportunities. We are using data analytics for creating a statistics, for it creates identified new opportunities where the data analytics have doing a cost reduction. It's doing for better marketing and product analysis, organizing analysis, and faster, better decision marketing. So this is the things where the data analytics have uses. Now, business analytics. So you know the terms using for the business analytics. So three things is coming for the data is in data analytics and decision. Data analytics and decision. So you can see here data is in scattered form. Collection of data is in scattered form. Here you can see a different colors. A different colors is showing a different data collection of a different resources as in unstructured and scattered form. Then analytics is after this analytics. After this analytics, we are putting these data in proper manner in a tabulation form. So this is the analytics. Computation tabulations is an analytics. Then After performing this data analytics, coming to the decisions. Decisions, it means we are putting our data according to related data. Okay, well, if we are saying blue colors are coming to the social media, pink is coming from the other males, this is coming from the different resources. So here isn't related data, and we can scatter for the decision. Finally, how the data you have pattern, how the data you have present. So this is the business analytics, examine larger and different types of a data to uncover hidden patterns, correlations, and other insights. So this is our data analytics and decisions. Okay, so this is our data analytics and decision, analytics and analysis. Visualization. What is data visualization? A data visualization is presentation of a data, huge amount of a presentation. So visualization allows us visual access to huge amount of data in easily digestible visuals. Okay, this is our visualization. Well-designed data graphics are usually the simplest and the same time for the most powerful. So you can say this is a pie chart, okay, bar chart, histograms, okay, hypothesis. So here we can, how you can present this at the presenting of our visualization. So this is our data visualization. These are the sources where we are putting our data for the data visualization. These are the company Sparks, Power BI, QuickBuilds, R, Python. Okay, so these are the data visualization sources. Now the why R, because if we are talking about data analytics, so without R isn't data isn't incomplete. Why R isn't language, isn't sources which share the tools which we are providing, is providing our data. So R isn't programming and statistical language. R isn't programming and statistical language, is apart from using a statistical language. It can also be used a programming language for analytic purpose. Data analysis and visualization. So apart from being one of the most dominant analytic tools, R also is one of the most popular tool for used for the data visualization. R is using as a data visualizations. Here, the simple way to easy of a learn, R isn't very simple. R is an open source and isn't very simple. We can read, write, and learn. R is in free, the liberal and open source, which means one can freely distribute copies of software reads. So then the source code is easily to modify and accessible. So in terms of visualization, so it helps the organizations, so the powerful of the most valuable assets, their data and the people. So in data visualization, we are presenting data visualization in terms of pie chart, bar chart, box plot, histogram, and line gram, and scatter plots. Because visualization means presentation of a data of any company. So they're the assets, they're the data and the people. So this we can show as either the pie chart, either the bar charts, either the box plots, histograms, and line grams and scatter plots. So this is the data visualization. Here you can see some example of the data visualization. So many examples we can perform using for the different charts. So here's an example of the data visualization. Now talking to terms of your data analytics tools. So first of tools is an R language, is an open source analytical tools. SAS, more popular is an SAS, and then over 8,000 packages available here for various kinds of this, big data platforms and data visualization as well. SAS in paid software tools, SAS is also present, is paid, SAS is in paid tools, but R is not R is an open source. You can easily access your R in your system. Versatile and easy to learn, SAS, and widely used for the industries. SAS very using for industry, software industries. SAS has tool for IoT analytics. So we are using for IoT analytics, pro analytics for SMEs, and anti-money laundering analytics. So this is we are using for SAS. Microsoft Excel, you all are familiar with the Microsoft Excel. The Excel is also a software tool for using your data analytics. Okay, so oldest tool, this is an oldest tool, or very simple for data analysis, widely used in industry. and combining data analysis for business analysis also, and very useful for the popular non-programming backgrounds also. Microsoft Power BI is another software paid tools. Okay, software, the many data sources and allow users to create report, display and dashboards. Helps users to apply machine learning models in built supports for Microsoft Azure cloud platforms, and dashboards can be combined from reporters. Tableau is a paid software also. Tableau as in software tools, but it's a paid software tool, very easy to learn, most suitable for creating data visualization, can handle more data than Excel, and can create interactive tools, interactive plots. Okay, this is Tableau. Python, very much popular for the Python. We are doing data analytics in Python also, Python and MATLAB also. Python free and open source. Python is an easily accessible, is an available for free sources, extremely versatile and powerful tool. Complete pipeline from data loading to data visualization to analysis. Pandas library, data load for loading. NumPy we are using, and SciPy, and for mathematical analysis we are using for NumPy and SciPy. Then matplots for data visualization. Okay, then relatively easy to learn compared to other languages. Large community supports. Now, these are introduction of the tools of data analytics tools, which their tools you can easily install your system. So some are such like Python, such your R, you can easily install. Microsoft Excel, these are open source. You can easily install. Excel isn't the packages of your Microsoft Office. Okay, so you can easily install, and you can do R language and Python also, because other are the paid tools. Tableau paid tools. Okay, then Microsoft Power BI is a paid tool. Then SAS is a paid tools. So these are the paid tools. But if you are doing, you can do in your R languages and in Python also. Now coming to our introduction to machine language. Machine language nowadays is very much popular for this. We are doing machine languages, you know. So machine learning, what is machine learning? ML or machine learning or language. Algorithm enables to computer to learn from data and even improves themselves without being explicit programmed. So this is a diagram of your machine. This one is machine robot, and this one is a human brain. It comprises of the both. So how machine has learned? Enables to algorithm for the computers. So it learns from the computers. It learns from the computers, what learns from the data, and even improves themselves. And then it's in explicit to the program. So this is what is machine learning. Now, machine learning comprises of the relationship between your big data and machine learning. You can say big data as in big the form of this, then data science and the data mining. These is comprises the machine learning, data mining, data science, and big data is comprises with the deep learning. And once we are saying a deep learning, it means as in machine learning, because machine has learned to our data from the computers, the data machine. Okay, then AI, artificial intelligence, entire once the relationship between how the relationship comes, once the entire things is coming is part deep learning, ML, machine learning, and then the relationship between your AI, artificial intelligence. Okay, so this is the relationship of your deep learning, machine learning, AI, and then big data. So here the relationship we are showing AI, artificial intelligence, machine learning, and then your deep learning. So deep learning, the data, here then the data of your coming, then neural nets, which is given the instructions, and then machine learning, who interaction with given to this machine learning. Once the entire things is coming, so we introduce our AI, is an artificial intelligence. If we can say artificial intelligence, if we can say AI, if we can machine learning, can say deep learning. So since an early flush of optimization in 1950s. So it's smaller subsets of an AI. You can say we can start from their time also. So well, first machine learning, the deep learning are subset of a machine learning, then have created ever larger disruptions. So AI isn't part of our past way. So AI is an early AI in artificial intelligence and states and excitements. So in coming to a 1950s, can see here is a robot which is coming from their times. The 1950s, 1916, 1917s introduced as an after this 1980s introduced a machine learning. Then machine learning begins of a flourish. Then 90s, 80s, 90s, and 2000 introduced as a machine learning. Then coming to deep learning, so 2010 onwards, it's a part of your deep learning. It means AI introduced received instruction from machine. Machine have working in the terms of so many things. They have received the instructions to the machine. Once is suppose if you can receive instruction from the machine, do like this. So this how it executed. So it's execute from the basis of this deep learning to background of AI. So it comprises this deep learning for the neural networks, neurons. You can say neurons have given instructions like you can do this, like and this. What next steps? What the sensors have come? What is the next things? Okay, so these instructions are coming from your deep learning and instructions received from the neurons, then machine learning, and then AI. Now the applications of AI, ML, and DL. So AI is in, if talking to data mining, initially because traditionally we were in data mining, then after this the data analytics and discovery, interpretations and communications of meaningful and patterns in data. So you can understand the data analytics in terms of data analysis. So analysis is in process inspection, cleaning, transferring, modeling data. Entire part have come into our data science. So in terms of data science is scientific methods, algorithms, and systems which extract to knowledge insights for the data. So in data science, if we are talking to data science, it's a part of analysis, data analytics, and data mining. Analysis, the term we are using, analytics terms we are a computational way. Okay, so this is the data mining. What the relationship? Because without data, everything is nothing. Without data, we can't do. Without data, it's necessary to data analytics to do as in deep learning. So if the inner part is in deep learning, why? Because how the technique, what the implementation, how techniques for implement machine learning. So suppose if we are saying self-driving cars or robots or speech recognition, this is a part of this machine learning or AI. Okay, so it's instruct of your machine learnings. So it's a part of your the deep learning. What instructions they have received. Then machine learning. Machine learning is a Google Maps, speed to traffics, Facebook facial recognition, Netflix videos recommended. So many things nowadays we are doing as a part of your machine learning. AI isn't like your AI is an human intelligence and then exhibited by the machines. Then Amazon purchase predictions and then smart email categorization. So this is our AI. The entirely things is comprises to your AI. So this is a relationship of your big data and the applications of AI, ML, and DL. The sources within we have received from the different mediums. And if talking to machine learning, any doubt is here? Any questions? Okay. Now the types of machine learning. You know, 3 types of machine learning. Machine learnings have 3 types. So machine learning can be broadly classified in 3 types of algorithm. Supervised, unsupervised, and reinforced learning. Supervised learning, unsupervised learning, and reinforced learning. Supervised learning. Okay, first is a machine, then supervised, unsupervised, and reinforced. Machine learning, supervised learning. Supervised learning has categorized in two parts in classification and regression. Completely. Classification is coming, image classification, identify fraud detection, customer retention, and diagnostics. Okay, classification is coming from these things. Then regression is a part of advertising popularity, predictions, weather forecasting, market forecasting, estimating estimating life expectations, and then population growth prediction. So this is the part of your supervised learning. Talking to unsupervised learning, then again unsupervised learning is a part of two, is in clustering and reductions, dimensionality and reductions. So if terms as a clustering, so clustering is in recommended system, and then target marketing. So how can target your market? Then customer segmentation, and then recommended the systems. Dimensionality reduction, big data, visualization, meaningful compression, structure discovery, and features elections. So this is our dimensionality reduction. So unsupervised learning have performing a two ways, clustering and dimensionality reductions. Then third is reinforcement learning, RL. So in RL, we are having, suppose example of a game AI, skill acquisitions, learning task, then robot navigations and real-time decision. This is reinforcement learning. So these is three parts, three important types of your machine learning. Now, in supervised learning, in AI, system is presented with the data which is labeled, which means that each data tagged with the correct label. Any example from your hands for supervised learning? Any example? Okay, so supervised learning is this learns. Supervised, suppose we are having, so instructions received from the computers, means machine. So if it's a well corrected label, which suppose you having your new mails, where the mail have comprised, a mail has a spam, or a mail is a not in spam, is in primary, or is in social, or it is promotional. So it is well categorized, well corrected label. So this is a part of your supervised learning. Suppose it learns, suppose this is a computer, a machine, this learns from the how it the data have come. It is well labeled which data have coming to the spam, which data has coming to a primary, which data is in promotional, and which data is coming your general items. So this is a well corrected level. So this is the example of your supervised learning. Okay, where the data is presented, which is labeled, which means that each data tagged with the corrected labels. So it enables the machine to be trained to classify observation into some classes. Okay, this is a supervised learning. Now, next example is an unsupervised learning. What is unsupervised learning? Where the presented is unlabeled and uncategorized data. This is a part of your unsupervised learning. It means unlabeled and uncategorized. There is the data is a system has an algorithm which acts as a data without prior training. This is unsupervised learning, that there is no trainings and there is no categorization over here. So here's in some example, you can see the picture of the here. So it comprises here the three things and the two things. So here is an example of your unsupervised learning, because no labeled is present is here and no categorization is present is here. So without any training, we are the example of your unsupervised learning. Any doubt? Any doubt?
If anyone has any questions, you can even write in chat box, or you can ask also. Yeah.
Okay. Then coming to reinforcement learning, RL. Reinforcement learning, RL. RL is in learning algorithm. Okay, RL reinforcement learning is a learning algorithm. It's based on agent-based or award and reward-based working. Learns by interacting with its environment. Learns by interacting with its environment. Then the agent received by performing correctly and penalties for performing incorrect. If it performs as in correctly, then it gives as in reward points. Okay, if it not doing any unperformed incorrectly, then it gives penalties. Okay, the agent learns without interventions from a human by maximizing its reward and minimizing its penalty. So it's an RL is an agent piece. Here is an award points, award and penalties. It is a type of dynamic programming that trains algorithm using a system of reward and punishment. Okay, so RL is a dynamic programming that trains algorithm using a system of rewards and punishment. So this is our RL, reinforcement learning. So here is an example of your reinforcement learning. Okay, example of a reinforcement learning. Here you can see 6 steps is here. Here you can see example of your RL. You can see here a machine. Machines have two instructions, whether the two path, whether it goes the fire side, whether it goes to the water side. It means that the environment, two environments here. Center one is an agent. Agent have observed as a two path. Okay, which path have chosen by the agent? If agent have select the fire path or fire policy, so in that case they get they'll choose an incorrect path. It means has in the reward penalties. So it's a penalties of 50 points have deducted. If have it's the next time, it means it receives instructions for the next time to give is this is not doing. It means if I'll choose a bad or incorrect path, so it will give you a penalties. Okay, so this is our agent-based RL reinforcement learning. Okay, if it's choose a correct point, correct path, it means path is chosen as in where the tap side, water side. It means it received a plus point, the action to get the rewards. If it will move from water side, so it will chosen 50 points or the reward points. Okay, and next time the good path is will choose according to this. Okay, so this is the process we are studying in our RL reinforcement learning. So this is update policy learning from the steps. So RL is basically for using our learning steps, whether which path we are choosing and what are the best path or optimal path policy we can choose. So for path finding, we can use for the RL also any kind of path. So suppose if you are the network side field, if you are having a dot networking, if you are then you can also apply RL is there for the transferring your node transfer. Okay, so this because it's chosen optimal policies, optimal policies is found here. So this is your the RL. So as an example, now can take some real world use case examples. For detection and anomaly, we are using real world for how to detect anomalies. So detect anomalies is termed of anomalies. For example, some volumes of certain products failing distinctly. So business needs to detect the such anomalies to ensure continuous operations. So detection of your anomalies, how anomaly we detected for using this. So this is an example of your real life. So contextual and collective outliers we have, global outliers, contextual outliers, and collective outliers. So this is a time series accurately predict anomalies in data sets. So here is a presentation of your data set. If you can say detection, so global outliers is presenting is this one is a global outlier. Contextual outliers, the presentation is showing is this, and then collective outliers, it means the both global and contextual, the presentation according to this. Now the industries, how the anomalous detection is applied. So in where they apply the telecommunication because anomalies is there, ad tax, e-commerce. So here they are the industries where we are applying for detection of your anomalies. How in telecommunication you can say a jitter measure of a jitter, latency, call qualities. The ADEX is an monitor click transactions and maintain quality of a marketplace. E-commerce field, e-commerce as an monitors to price glitches, detect websites load to prevent crashes. So here the industries, some general industries which you are using in real life, they are using for detection of and applied for this. Industries where anomalized detection is applied in fintech, identify anomalized customers' behavior to mitigate fraudulent and transactions. Online business, detect anomalized fraud API behavior, performance root causes analysis. Because anomalies is everywhere. Anomaly, we are not aware where the anomaly is there. So in real world, we are using anomaly detection. So how we can detect anomalies and what are the industries they are using for anomalies and how they can detect. So here are some examples over here. So it requires combines of supervised and unsupervised learning. Supervised learning helps to create rules and determining whether an outlier is an anomaly or not. Unsupervised, it means it detects an anomaly has occurred, sent a notification. And time series analysis where effective anomalous detection techniques. So how do you detect anomalies? That's why if anyone is in field of ad hoc networking or network sites, because there is also we are choosing a path detection, path finding, node detection from moving a path from one node to another nodes. So we are going to a best optimal path. So according to using for RL or machine learning for apply, your node is in machine learning also. So you can detect your good path. Here is some other example of smart energy virtual power plants. So this is an example where we are using for this machine learning also. Some smart virtual power plants. You can see some example. Then our industries also virtual power plants. So energy efficient power plants are need often the reduction of greenhouse gases. Germany industries in German industrial sectors uses 25% of energy consumptions of which 66% of heating and 26% is electrical uses. Then 20% energy saving can be achieved using optimization techniques. So how we can save our energy and how we reduce all the greenhouse gases. The main problem the power generation is an energy supply and demand of unbalanced. Storing energy is cost affair and achieving the balance between energy generations and consumptions is critically as the causes price spikes. Then virtual power plant. Virtual power plant. So here's an example of your virtual power plant. So this is your, suppose this is your power plant in this graph, and here is a natural gases, and this one is your the sides the heating damage, how it's damaged to the heating. So here the virtual power plant, suppose solar plants or windmills, it generates to electricity. In terms of this, it generates to electricity, then bifurcate your electricity to the as per demand, and then cooling demands and then heating demands. So this is your virtual power plant. So software defined a virtual power from the sources from the different. Then virtual power plants as a VPP is a network of decentralized medium scales power generation. Virtual power plants operates taking into account energy consumption forecast, and then optimizations is done using the internal coefficient of performance and external factors such like your gas, coal prices, where you can generate your power. Kaggle and real world data sets. Kaggle, you all are familiar. Kaggle is a data sets we are collecting from the Kaggle. So Kaggle contains over 50,000 data sets, which are all open sources. Okay, it provides a very good platforms to test our models and get community to help. And Kaggle also provides its own cloud where you can run Jupyter Notebook. It's in Python. Okay, movie recommended system. So it's a Netflix. These are the general examples we are using for the real life. Netflix and AI-based movie recommended to improve user experiences, where we are using for the data set, data analytics and machine learning both. So the simple idea behind the system is if a person likes three similar movies, suppose for example XYZ, the person B like movies in X and Y, then how likely it's present for the person of B and will also like the movie for the person of Z. It's a simple way. If the three person have liked the same movies, so it's not necessary B is like the X movies and FZ is like the same movies of the which the B have likes. Isn't B likes movies X and Z, then how likely you can say the person B will also like movie Z. It's a simple example. This technique is also known as collaborative filtering. Some examples you can see here, the collaborative filtering. Sources of a Netflix. These sources we can collect a Netflix also. So here we are person, we can collect, I can like this movie and you the second person I didn't like this. So 4 examples is here. One is in social media, another is books, another is like movie play, and then video games. Person 1 is like these 3, not a 4. Person 2 is like, not the first person, he don't like the movies and pictures, he like the book and not other things. Means only person 2 have like only 1. Person 3 is like only out of 4, he likes or he or she likes other 2 things, movie and books. Person 4 have likes only 1, which is the videos, movies. Okay, and person 4, fifth one person, have likes is in only 2 out of 4. Other things as dislikes. So this is called a collaborative filtering. We can filter of the different sources. So it's not necessary either if 3, 4, 5 persons is there or a group of a persons is there, so their likes are the same. So that we can identify this how they can like this. Now the machine learning model, so practical if machine learning models to use this task is a 2-layer neural network. So rectified linear unit activations, so rectified fx is in max is a 0. Then for regularizations we used dropout, and the techniques we ignore output of the some neurons, and this neurons the network does not and outfit. Some data analytics companies, so many data analytics companies and ideas are like SAP, Oracle, Plantur, Accenture, Tableau Software. These are the data analytics, some examples of a data analytics company. Using Industry 4.0, nowadays, Industry 4.0 we are using. And how did we get here? So we get, suppose 1, 2, 3, 4, the sources, machine, the mechanism, and mechanizing, streams engines, water, stream power, manufacturing, textile industry, metallurgic machines, books, streams and factors. Then technological electrifications, production lines, mass productions, globalizations, and engines. Third, the source get from computer, network, internet, digital manufacturing, robotics, IT, IoTs, digitizations, automations, electronics, so network digital machines. 4 sources is in convergence of IT, OT, automations, machines, advanced robotics, big data analytics, Internet of Things, digital ambiguity, cloud smart factors, machine learning, and AI. So we get Industry 4. If we are talking to Industry 4.0, so Industry 4.0 is complete. Every industry have cumulative over here. Mechanisms, technological, network, digital manufacturing, IoTs, so different 4. So we get the different 4 sources. So timeline of Industry 4.0. So term was combined for this terms Industry 4.0 combined by German scientist Wolfgang Wallhuster. The idea behind Industry 4.0 is computerization of manufacturing. The goal behind Industry 4.0 is to ensure flexible mass production. This is the key concept of Industry 4.0, and the key concept because Industry 4.0, it means cybersecurity, alternate learning, Internet of Things, cloud computing, system interaction, simulation, and then the associative, so many things, big data, so many. Industry 4.0 is comprises 3 key concepts, is everything. What is the role of AI in Industry 4.0? The role of AI in Industry 4.0 is the following: is an environmental perception, process perception, inferences, and problem solving and decision making. Flexible was production of batch manufacturing of customized goods, manufacturing process monitoring, planned outage for maintenance and repair, then predictive maintenance of facilities and machines, better planning of resources uses, and hence reduced consumption. This is the role of your Industry 4.0. So, summarize the way and premises of Industry 4.0 is data collection, storage, and analysis. So, what is Industry 4.0? So, this is basically a collection of a data, storage of a data, and analysis of a data. This is a Industry 4.0. So, now the data flow, how the vertically have integration of data, Industry 4.0 data is flows. You can see here a graph. Here a pyramid. In pyramid, in the base is in sensors and actuators. Actuators and sensors has in base. There is an interfaces and production process. This is your field level. Level 2 is in regulation of machine system. It means PLC, so program logical controllers. Level 2 is in program logical controller. This is the control level. Here, level 3 is in SCADA. SCADA means industrial control systems. There, the entire industry is there. SCADA is production level. Level 3 is in production level. So there, in production level, they can use a monitoring controls and supervision products finds. Then operation levels. Operation levels, it means level 4, MES. Then level 4 is there. The production planning, quality, managing OE isn't coming to the level 4, is an operation level. Level 5, top level, is an enterprises planning level. ERP, enterprises planning level. It means the ordering, management, processing enterprises, production, planning, and business. So this is a ERP. It's a top is in the pyramid, top of the pyramid is ERP. Then entirely is coming to the vertically integration of system across the hierarchical levels. Entirely is coming from the system as in hierarchical levels. So this is the data flow of Industry 4.0. Now the software tools enabling Industry 4.0. What are the software tools in the Industry 4.0? OPC this is in foundation, unified architecture. OPC is in foundation to machine communication protocol developed by OPC Foundation, based on client server communication, open source based on GPL 2.0 license and cross platforms, service oriented architecture. OPC as a software architecture. So there is example of OPC. OPC how is works because OPC is in develop foundation. It develops client servers and pub use case a specific protocol mappings. So it's a client servers and public server. Then information model access. Information model access, it means the browse client server is in browsing, accessing, semantics, excuses, and configure. Public service means data and events notifications. Information model access, then information model building books. So it means the meta models. Then core information and company's information. So this is the vendor specific mentions. OPC uses SDK unified automations. It means it provides SDKs, C++, Java, and .NET. It's in unified automations. Software products like UA exports, UA gateways, and UA models. Unified authentications. MT Connect is a manufacturing technique, standards for retrieving process information from CNC machine, and uses open source communication protocols based on XML and HTML for real-time communication between machines on shop floors. This is your MT Connect architecture. In MT Connect architecture, we are having brand X and brand Y in MT Connect. So we are having different machines is using from X, Y, and Z. So this is an architecture of different brand and different companies. MQT uses CAST, then automatic and logistic. So this is in, suppose BMW is an automatic, you can use the BMW car for sharing applications and doing for this. Logistics in web such as drone-based deliveries. Manufacturing used for the power plant and monitoring. Oil and gas is a monitoring for functionality in oil and rings. So this is the MQTT use cases. Azure IoT. Azure IoT is in hub. So Azure IoT, Internet of Things, provides a collection of cloud services of data, monitoring, connections, and control. IoT devices usually consist of remote sensors, which connects the Wi-Fi. Examples of pressure sensors on remote oil pumps, on accelerators, on and elevators. We are using for your Azure IoTs. Azure IoT is technologies. So Azure is using for IoT is centralized applications. There are the IoT solutions. Azure services for IoT is IoT and edge device services. So in IoT for the company of Azure is technology using for this IoT is retail, health, energy, and government sectors. Cyber physical systems, digital transformation in shipbuilding industries, smart energy management, virtual power plant, conditions monitoring in smart manufacturing, and smart monitoring based on novelty detection and AI based. Some examples of shipping industries also, shipbuilding industries. So shipbuilding industry, so like manufacturing the process, wide range of involved in elements, low volume serials productions, complex projects difficult to manage and execute. Two most important problems in organizations and technologies. Now existing technologies, so traditional methods of projects taking using scatters documentations, manual qualities, inspections of sophisticated part, manual projects for taking using traditional methods without use of digital technology. So this is the existing technologies we are doing. Now, what solution AI and analytics process? So here is an AI, learn manufacturing, AI and ML and data analytics. So learn manufacturing, here how they can learn. Value streaming, single, 5S, 5s, SMEDs, Kanban, JIT, GTPM, and learn. Open research areas. So we are using in our research areas. So what are the open research areas in our field? Data set creations in the context of Indian manufacturing industries and challenges faced by them. So consumer behaviors and buying patterns and analysis of geospatial data of how rises changes their flow to create effective flood warning system, and then weather pattern analysis to help a farmer optimization, then crop plantations. Okay, now I conclude my presentation. So any questions? Any questions? Any questions? Any questions?